Okay, so we want to just get practice with that, being able to translate from the definite integral into the Riemann sum. So we have several examples here that we want to run through. You can try to work these on your own and then come back to the video and check to make sure that you've done it if correctly if you need an explanation. I will also, if I have not already, go ahead and post the answer key to the notes so that you'll see what you should have gotten, and then you can refer back to the video for an explanation if you need that. Okay, so here we've got the integral from 2 to 4 of 3x squared minus 1 dx. And I want to write this as a Riemann sum. So first thing I need to know is what is delta x? Delta x is going to be 4 minus 2 over n. All right, the next thing we need to figure out is what our x sub k's are going to look like. All right, so x sub k is going to be 2 plus delta x. So delta x is 2 over n, right? 4 minus 2 is 2. So we get 2 over n, okay, times k. All right, those are our x sub k's. And so f of x sub k okay, this is our function f, 3x squared minus 1. So I need 3 times 2 plus 2k over n squared minus 1. Okay, and we need to clean that up. Well, we'll leave it like that for now, since we don't have to do this by hand. All right, so then I've got my f of x sub k. I know what my delta x is, so I'm ready to write my limit. Okay, the limit as n approaches infinity, okay, of the summation of k equals 1 to n, okay, times delta x is our width. So we said that was 2 over n. Because there's no k in that, I can write that 2 over n outside of the summation, okay, and it would have been delta x times f of x sub k. Well, our f of x sub k is 3 times 2 plus 2k over n squared minus 1. All right, that's what we got. Okay, we want to check to be sure that this expression that we just come up with gives us the same value as the integral that we started with. So we'll use our calculator for that. All right, we'll do the integral first. So we can go to math, and we're going to go down to option 9. If we remember that it's number 9, we can just hit the 9 key to get there more quickly. Okay, we're integrating from 2 to 4, and our expression is 3x squared minus 1. And we're doing this for variable x. All right, and so we get a value of 54. Okay, so just as a check, we want to make sure that if we did this with our what we've come up with as the expression for the Riemann sum, that it gives us the same thing. Okay, so we'll go back to y equals, and we're going to put in the expression. I'm going to do 2 over x. Remember, we're doing for n, we're using x, so that it'll be easy for us to plug those in. So just 2 over x, that was our width. Okay, we've got the same summation, k equals 1 to x. And then over here is where we're going to put in our actual expression, which is going to be 3 times 2 plus 2k over n, so alpha k divided by n, or x for us, squared. Okay, we're going to close that off and square it. Okay, minus 1. Okay, we want the summation of all of that. Now we got two things we have to deal with. One, did we come up with the correct expression? And two, did we enter it correctly? But, you know, we'll get there with practice, but I'll just scroll through here again briefly so that you can see what I have entered. All right, so I'm going to get out of here and let's look at y of 10, or f of 10. Okay, so this is what we would get at 10 rectangles. Okay, we're in the ballpark, but we're still a ways off. So let's try, I'm gonna go ahead and push it up to 500 rectangles. Okay, now we're getting very close. Okay, and I'll just do one more. Let's maybe do, dare I, 1500 rectangles. Okay, it's thinking, but it got there. Okay, we won't test it beyond that, but we can see that as we're increasing the number of rectangles, it is going towards the same value of 54. All right, so let's try that again with B.